acids, alkalis, and pH. Acids are substances that give up an ion in an aqueous, water, solution. They turn blue litmus paper red, and have low pH numbers. Acids are also sour tasting. Lemon juice and vinegar are acids. Because acids lose an ion, they are efficient at neutralizing alkalis, which uptake ions. Alkalis, also called bases, are substances that take on an ion when in aqueous solution. They turn red litmus paper blue, and have high pH numbers. Alkalis are bitter tasting, think ammonia, and have a soapy, slick feel. Because alkalis accept ions, they are efficient at neutralizing acids. pH is a measurement of the relative acidity or alkalinity of a solution, which is determined by its concentration of hydrogen ions. Chemists have created a pH scale that ranges from 0 to 14. On this scale, pure distilled water has a pH of 7, which is neutral. Solutions with pH less than 7 are acids, and those with pH greater than 7 are alkalis. Figure 1.3 illustrates the pH scale, along with several common solutions and their pH levels. Carbon and organic chemistry. Organic chemistry is a specialized field of study focusing on carbon-based molecules. The significance of carbon is its presence in all living things on the Earth, as well as in the fossil fuels we burn to power the machinery of modern life. Physics. Physical science, normally called physics, is the study of the relationship between matter and energy in all its forms. The most fundamental aspect of physics is that of mechanics, which is the study of how physical objects move and the forces in play against them. Chapter 7. Mechanical Comprehension discusses the field of mechanics in depth. However, all the other concepts of the physical sciences are discussed here, except that of electrical energy, which Chapter 6, Electronics Information, discusses. Mechanical motion. The terms work, energy, and power are commonly used in our language and mean different things in various contexts. In science, however, each has a precise, quantifiable meaning. Although Chapter 7 covers this information in detail, the following serves as a quick introduction. Work, the product of an object's displacement, distance moved in the direction of a given force, and the force used to move the object. The SI unit of force is the Newton. N and work is measured by the joule J. You may also see work quantified by the foot-pound, FTLB. Regardless of the unit of measurement, the equation for work is work equals force times distance, or W equals FD. Energy, the ability to do work. The SI unit of work is the joule J. Although energy comes in many different forms, such as chemical, electrical, and nuclear energy, as related to mechanical energy, there are two types. Kinetic energy, energy in use or motion. When you swing a hammer and strike a nail, the resulting work is done by kinetic energy. Potential energy, stored energy, resulting in an object's position, configuration, or lack of motion. A ball lying on the ground has potential energy, whereas a ball in mid-flight is exercising kinetic energy. Power, the rate at which work is done. The SI unit of power is the watt, W, or FTLB. The equation for power is power equals work time, or P equals WT. Newton's first three laws of motion, which Chapter 7 discusses, establish the foundation for the study of mechanical motion and address these quantities. Speed, a scalar, specifies quantity only, with no information on direction, expression of distance traveled per unit of time. Velocity, a vector, specifies quantity and direction information, expression of distance traveled, called displacement, per unit of time. Acceleration, a change in the velocity of an object over the amount of time required to make that change. Force, the push or pull that imparts motion on an object. Mass, a measure of the quantity of matter contained in an object. Mass is a constant value, regardless of the effects of gravity acting upon it. Not to be confused with weight, which considers the effects of gravity acting on an object's mass. For example, due to the weaker gravitational pull of the moon, a person would weigh less on the moon than on Earth, whereas that person's mass would remain constant. Newton's second law states that momentum, p, is the product of the mass, m, of an object, and its velocity, v, or p equals mv. Note: thermal energy. Thermal energy, or what we call heat, is the energy created by the movement of a substance's molecules. Heat flows from a substance that is hot to a cooler substance with which it comes into contact. The SI unit of measurement for heat is the calorie. The three ways that thermal energy is transferred are as follows. Convection. Heat transfer occurs because of movement caused within a fluid by the tendency of hotter, and, therefore, less dense, substances to displace colder, denser material. Conduction. Heat is directly transmitted through a substance, without movement of the material, when there is a temperature difference between adjoining regions. Radiation. Heat transfer occurs through the emission of electromagnetic waves, which stimulates molecular activity. Therefore, the thermal transfer requires neither direct contact between the two media nor a connecting medium. This is best seen when considering how the sun heats Earth, via radiation, across the vacuum of space. Sound energy. Sound, both audible and inaudible, travels in regular, measurable waves from the source. In physics, waves are disturbances that move progressively through a medium, in a given direction with repeating peaks and valleys of motion. Figure 1.4 demonstrates a wave, longitudinal waves in the air. Waves are specified by measuring their wavelength. The following are the measurable characteristics of sound waves. Frequency, the measurement between sound waves, usually specified as the number of complete cycles of signal per second. Frequency is measured in hertz, and normal human audible sound is 16 Hz to 16 kHz. Amplitude, the value of the maximum height of the wavelength above the mean value of the wave. It represents the strength of the signal at any instance. Wavelength, the distance between corresponding points on adjacent cycles. Y. X. Amplitude. Amplitude. Wavelength. A waveform. Figure 1.4 A sinusoidal wave. The Doppler effect is generated by a moving source or detected by a moving observer. In the case of sound waves, when a listener hears a noise source approaching, its frequency appears to increase the closer it gets. The moment the noise source passes its nearest point to the listener and begins moving away, its frequency appears to change. Think of how an emergency vehicle's siren sounds as it goes past. This effect is useful in radar, sonar, and sonogram applications, because the shape of the returned signal indicates the size and distance of the object.